The universe is full of wonders. For centuries humans have tried to understand it. One way we make sense of the universe is through mathematics, but calculations can be complex and time-consuming. Long ago people invented tools to help them calculate. One of the earliest calculating tools was the abacus. It used beads on rods to represent numbers. With an abacus, people could add, subtract, multiply, and divide. Another important invention was the astrolabe. Sailors used it to navigate by the stars. These early tools were crucial for their time. They helped advance trade, exploration, and scientific discovery, but they were limited in their abilities. The dream of a machine that could perform more complex calculations was yet to be realized. The 17th century brought a new era of calculation: mechanical calculators. These devices used gears and levers to perform arithmetic operations. One of the pioneers of this era was Blaise Pascal. Pascal invented a mechanical calculator called the Pascalin. It could add and subtract numbers. Later, Gottfried Wilhelm Leibniz improved upon Pascal's design. Leibniz's calculator could also multiply and divide. These mechanical calculators were a major step forward. They automated calculations and made them faster and more accurate. However, they were still limited in their complexity. They could only perform pre-programmed operations. In the 19th century, Charles Babbage envisioned a truly revolutionary machine: the analytical engine. Babbage was a brilliant mathematician and inventor. He conceived of a machine that could be programmed to perform any calculation. The analytical engine was designed to use punch cards to input instructions and data. It would have had a memory unit to store information and a central processing unit to execute instructions. Although it was never built due to technological limitations of the time, Babbage's analytical engine laid the groundwork for modern computers. Ada Lovelace, a brilliant mathematician, collaborated with Babbage. She recognized the immense potential of the analytical engine. Lovelace is considered the first computer programmer. She wrote algorithms for the analytical engine, demonstrating its potential beyond mere calculation. The 20th century marked the dawn of the digital age. Scientists and engineers made breakthroughs in electronics. These advancements led to the development of the first electronic computers. These early computers used vacuum tubes. Vacuum tubes controlled the flow of electricity. They acted as switches and amplifiers. One of the first electronic computers was ENIAC. ENIAC was enormous, taking up a large room. It was used for complex calculations, including those for the Manhattan Project. Another groundbreaking invention was the transistor. Transistors were smaller, faster, and more reliable than vacuum tubes. They revolutionized electronics and paved the way for smaller and more powerful computers. Section 5. Code breakers and computers, Turing's legacy. During World War II, the need for fast and efficient computation became even more critical. Code breaking played a vital role in the war effort. Alan Turing, a British mathematician, made significant contributions to this field. Turing developed the concept of a theoretical computing machine, now known as the Turing machine. It provided the foundation for theoretical computer science. Turing also played a pivotal role in breaking the Enigma code used by the Germans. His work not only helped shorten the war but also laid the groundwork for modern computer science. The Turing test, which assesses a machine's ability to exhibit intelligent behavior, is named after him. Section 6. Silicon Valley and personal computing. The invention of the integrated circuit in the late 1950s was a game-changer. Integrated circuits combined multiple transistors on a single chip. This miniaturization led to a rapid increase in computing power and a decrease in size and cost. The first microprocessors, like the Intel 4004, emerged in the 1970s. These tiny chips contained all the essential components of a central processing unit, or CPU. The stage was set for the personal computer revolution. Companies like Apple and Microsoft played a pivotal role in bringing computers to the masses. Apple's Apple II and Macintosh computers, known for their user-friendly interfaces, made computing accessible to a wider audience. Microsoft's operating systems, particularly MS-DOS and later Windows, became the dominant software platform for PCs. Section 7. The Global Network, Connecting the World. The development of the Internet in the late 20th century transformed the world into a global village. The internet connected people and information like never before. It originated as a research project funded by the U.S. Department of Defense. Tim Berners-Lee invented the World Wide Web in the early 1990s. The World Wide Web made the internet accessible to a broader audience. It introduced user-friendly web browsers, websites, and hyperlinks. The internet's impact on society has been profound. It has revolutionized communication, commerce, education, entertainment, and countless other aspects of our lives. Section 8. Computing today. From smartphones to supercomputers. Today, computers are everywhere. They are embedded in our smartphones, cars, appliances, and countless other devices. We live in a world driven by data and computation. Smartphones have become ubiquitous, providing access to information, communication, entertainment, and more. Supercomputers, on the other hand, perform highly complex calculations for scientific research, weather forecasting, financial modeling, and other demanding tasks. Cloud computing has become increasingly popular. It allows users to access computing resources over the internet, eliminating the need for powerful personal computers for many tasks. Section 9. The future of computing, artificial intelligence, and beyond. The future of computing holds exciting possibilities. Artificial intelligence, or AI, is rapidly advancing. AI involves creating computer systems capable of performing tasks that typically require human intelligence, such as learning, problem-solving, and decision-making. Machine learning, a subset of AI, allows computers to learn from data without explicit programming. This has led to breakthroughs in areas like image recognition, natural language processing, and self-driving cars. Quantum computing is another area of active research. It harnesses the principles of quantum mechanics to perform computations that are impossible for classical computers. Quantum computers have the potential to revolutionize fields like medicine, materials science, and cryptography. The future of computing is full of unknowns. But one thing is certain: computers will continue to shape our world in profound ways.